Now, in our previous classes, we have also defined what is meant by the operator del. This del operator is equal to dou by dou x of ax, dou by dou y of ay, and dou by dou z of az. Okay. So here you already observed dou by dou s of ax, dou by dou y of ay, dou by dou z of az. Okay. So can I write del dot, again d you are having, del dot d bar is equal to simply dou dx by dou x plus dou dy by dou y plus dou dz by dou z. This is nothing but the divergence of vector d bar. This is divergence of vector d bar. This divergence is also given as del dot d bar equal to closed surface integral of d bar dot ds bar by delta v. This term is also equal to this equation. No? So I am substituting that here. That is also equal to q by delta v, because here we have written that. Now all these are equal to dou dx by dou x plus dou dy by dou y plus dou dz by dou z. Okay. So this is called as divergence. Mathematical expression for divergence. So let us solve a small problem based on this divergence concept. Suppose sometimes they will give you the electric flux density d bar in vector form. Let us take it as some 2xy into ax plus 2z square into ay plus 2yz square into az. Okay, so this is the function for electric flux density d bar. Now they are asking you to calculate, find the value of del dot d bar at a point of 2, -1, 3. Let us take some point. Okay, so they have given you d bar expression like this. They are asking you to calculate del dot d bar at some point 2, -1 and 3. Okay, so we already know that del dot d bar is equal to dou dx by dou x plus dou dy by dou y plus dou dz by dou z. That means dou by dou x, partial derivative of what is the x component that is present in the given function, 2xy, plus dou by dou y of what is the y component that is present in the function, 2z square plus the z component that is present in the function is dou by dou z of 2yz. Okay, this is the 2yz square as I have given z square. Okay, so if you find the partial derivatives of those, you can obtain the final expression for del dot d bar, which is equal to, what is the partial derivative of 2xy with respect to x, 2y. Partial derivative of 2z square with respect to y, 0. Partial derivative of 2yz square with respect to z, 2y is a constant, derivative of z square is 2z. So 4yz. This is the value of del dot d bar. Now in the place of this x, y, z, you can substitute this 2, -1 and 3. So final expression is 2y. That means 2 into what is y value, -1, plus 4 into yz means what is y, -1 into z value is 3. That means -2 minus 4 3 is 12, which is equal to -40. So this is the value of del dot d bar for the given function, which is equal to -40. Okay, these are the simple problems which may come from this topic. Next, we have represented the divergence. We have represented the divergence in mathematical form. Okay. Next, we need to know the meaning for divergence. What is the physical meaning of divergence? Before that, let us go for Maxwell's first equation. That means these expressions can also be further improved as Maxwell's equation, which is also called as point form of Gauss law. Why I am repeating this concept means the curl concept, CURL, curl concept in second unit is also similar to this. Once if you understand this, understanding that curl in second unit is also very easy. That's why I am repeating this concept. So now we know that the integral form of Gauss law is Q equal to surface integral of d bar dot ds bar, and we already know that del dot d bar is equal to dou dx by dou x plus dou dy by dou y plus dou dz by dou z, okay, which is equal to del dot d bar is equal to this formula, and also integral d bar dot ds bar by delta v, or that is also equal to q by delta v. As I have said that this differential volume will not stay constant. This volume will always shrink to zero. That means again you will reach to the point P only. This volume will slowly compress and it will become zero. That means if volume becomes zero, can I apply limit delta V tends to zero on both sides? Let us apply that limit. Delta V tends to zero. Integral d bar dot ds bar by delta V is equal to limit delta V tends to 0 q by delta V. Okay, but we already know that q by delta V is equal to rho V. That means volume charge density. Volume charge density is equal to the total charge in that volume divided by volume of that body. So in the place of q by delta V, what I can substitute? Rho V, okay. And what is this integral d bar dot ds bar by delta V? That is equal to del dot d bar. So here I can write del dot d bar is equal to and in the place of this q by delta V I can write rho V. Okay, this is called as del dot d bar is equal to rho V. So what is the final expression here? Del dot d bar is equal to rho V. This is Maxwell's first equation. Maxwell's equation, or this is also called as point form of Gauss law. Point form of Gauss law. Okay. Del dot d bar equal to rho V is also called as Maxwell's equation or point form of Gauss law. Now, let us see what is meant by the physical meaning of divergence. What is the physical meaning of divergence? We have already derived the mathematical expressions, but we need to know what is the physical meaning of divergence. Suppose we know that electric flux is equal to total number of electric flux lines, electric lines of force passing through a surface. Now, suppose that there is a point P. There is a point P in a closed surface. The flux lines are leaving from this surface. The flux lines are leaving from this surface. This is positive divergence. So now suppose at this point P the flux lines are coming, the inward flow of the flux lines. Positive divergence means the outward flow of the flux lines from a closed surface or closed volume when the volume shrinks to zero. The inward flow can be treated as negative divergence. Okay. This is negative divergence. And suppose if at a point P some amount of flux lines are coming and the same amount of flux lines are leaving. If some amount of flux lines are coming and the same amount of flux lines are leaving from that point, then here we can say that the divergence is 0. That means how can we define divergence? Divergence is outward flow. Divergence is outward flow of flux lines from a closed surface as the volume shrinks to 0. As the volume shrinks to 0. Okay, that means I said that this volume will not stay constant. It will become 0 at some time. So as the volume becomes 0, the outward flow of flux lines from the closed surface is called as divergence. That means from this volume there is a point P. From that point P some amount of flux is going out. That is positive divergence. If you are considering the inward flow of the flux lines, that is negative divergence. If same amount of flux lines are coming to that point and they are leaving from that point, that is zero divergence. Okay, this is the physical meaning of divergence. This is the application of Gauss law for a differential volume element. Okay. Now finally we are going to deal with divergence theorem. So the last concept is divergence theorem. So here this divergence theorem states that any vector D or A can be converted from a surface integral to volume integral. Any vector D or some A can be converted to surface integral or volume integral. Let us see how we can convert that. From Gauss law, we already know that Q is equal to closed surface integral of d bar dot ds bar. From Gauss law, Q equal to closed surface integral of d bar dot ds bar. And we also know that from the previous expression Q equal to integral rho v dv, because rho v is equal to Q by delta v or dv. Volume charge density rho v is equal to charge divided by the volume. For a differential volume you can take delta v or dv, that is our wish. So using both these expressions, both are Q's only. If LHS are equal, then RHS can be also made equal. So closed surface integral of d bar dot ds bar is equal to integral rho v dv. But from the Maxwell's first equation, what is the formula for rho v? In the place of this rho v, what I can write? We know that rho v is equal to del dot d bar from the Maxwell's first equation or point form of Gauss law, which we have derived earlier. Now in the place of rho v, what we can substitute? Del dot d bar. That means surface integral of d bar dot ds bar is equal to volume integral of del dot d bar dv. That means on LH side you are having surface integral, on right hand side you are having volume integral. For a given volume of the element, a surface integral can be converted to volume integral with the help of this formula, and this particular concept is called as divergence theorem. Okay, this is the concept of divergence theorem. By using Gauss law, Gauss law is applied to a differential volume element to understand the concept of divergence. So finally divergence theorem states that the surface integral d bar dot ds bar is equal to, that means it is converted to volume integral of d bar, that means integral del dot d bar dv. Surface integral can be converted to volume integral with the help of this divergence theorem. Gauss law is applied to a differential volume element to understand the concept of divergence. To understand the concept of divergence, Gauss law is applied to a differential volume element. Now, in second unit, to understand the concept of curl, C-U-R-L, curl, we can apply Ampere's circuital law. Already we have discussed what is meant by Gauss law and everything, and we have applied that Gauss law to a differential volume element, and we have proved some concepts for divergence.